Refer to question number 14. This acid is known as squaric acid. The question asked there in the one is, the cyclic compound is almost as strong as sulfuric acid. As we all know, sulfuric acid is one of the strong protonic acids. This acid which is known as, actually there is no carboxylic group here, but even then the acidity of this compound is as strong as the protonic acid, which is sulfuric acid. What is the reason for this? The reason is very simple. It is stabilized by resonance. I will just give one or two simple resonance structures. Supposing one hydrogen goes off from here. So what we will get? Resonance structures are always represented by means of a double-headed arrow. So you have the two CO groups being retained, and then we have a double bond here. We have OH also here. This hydrogen goes off and comes over here. So this double bond goes over to this place. This goes over to here. No? Extended conjugation. Like this we can write a number of structures. Instead of writing it here, we bring the double bond here. So the other resonance structure will be, we have a double bond here. This single bond will move to this. This will become a double bond. Similarly, we can bring the double bond here. Instead of moving the double bond to this place, we can move over to this and then move over to this, like this. This is for one of the OH groups. The other OH groups can also write similar structures. A large number of resonance structures can be written. So it is very much resonance stabilized. Therefore, this loses its hydrogen, or this loses its hydrogen in the form of proton, and this is highly acidic. So that is why it is said it is as strong as sulfuric acid, inorganic acid, which is sulfuric acid. So that is the question number 14. Regarding question number 15, it is very simple. Phenol is a stronger acid. Consider this to be an acid. When we consider this to be an acid, what does it mean actually? This hydrogen must be lost and the O minus here must stabilize. Whereas in the case of phenol, the phenol is definitely a stronger acid because the phenoxide ion which is obtained by the loss of a proton has this structure. Immediately, negative charge on the oxygen gets delocalized into the ring. You can draw as many as about 5 resonance structures for this, but nothing can be drawn for this. Therefore, this cannot lose that proton very easily. Assume this proton is lost, and we have, assume this proton is lost, and what we have here, we have minus charge, and it is not so easy to get delocalized into the ring. Therefore, this cannot be that much acidic, and this is definitely acidic because proton is lost and the phenoxide ion is a stronger acid. It is not more than the phenol, the phenoxide ion gets stabilized by resonance. So the conjugate acid of, the conjugate base of phenol, which is a phenoxide ion, gets stabilized by resonance. Whereas such a type of resonance stabilization is not so, is not possible at all in this. That is why phenol is a stronger acid than this acid. This acid is actually given only for comparison, and phenol is, we can draw several resonance structures, we cannot draw that many resonance structures for this.